Myself Shubhashish Shah, Assistant Professor of Mathematics of Greater Kolkata College of Engineering and Management, GIS Group. In this video, I will discuss how to find the particular integral if the right hand side function is a product of exponential function and a polynomial or sine function or cos function. In the previous videos, I have discussed if the right hand side function is a sine function or cos function or exponential function or polynomial function. These were all individual functions. Now it will be a combination of two functions. So if capital X is e to the power x into sine ax plus b or cos ax plus b or polynomial function. So e to the power x is fixed, product of e to the power x into and some any of this function. Then pi equal to 1 by function of d, and I am writing this as capital X. The method is you have to put d equal to d plus a and operate on the function highlighted in this box. That is, if suppose the function is capital X is e to the power x into sine function, then you have to put d equal to d plus a and operate only on the sine function, and then you know what how to find the pi for sine function, and you have to apply that rule. I am giving an example. Suppose the pi is 1 by d square plus 2d plus 1 operating on e to the power 3x into sine 2x. Then we have to put d equal to d plus a, that is here a equal to 3, so we will put d plus 3 whole square plus 2 into d plus 3 plus 1, and we will operate only on sine 2x, and I have to write e to the power 3x in the first position. So this will be e to the power 3x into 1 by d square plus 8d plus 9 plus 6 15 plus 1 16 after simplifying sine 2x. So exponential function, you will have to write this in first, then operate only on the remaining function. Now it may be sine or cos or polynomial, you will have to apply the corresponding rule. You have to, in this case, you have to apply the rule for sine function, that is I have discussed before. For sine or cos function, we have to put d square equal to minus a square. So here we have to put d square equal to minus 4. So minus 4 plus 16, that will be 12 plus 8d sine 2x. Now, since there is no d square in the denominator and we need d square in the denominator for sine cos function, for putting d square equal to minus a square, so we will multiply by 8d minus 12 in the numerator and denominator. It will give us d square in the denominator, so that we can put minus a square in place of d square. So after multiplying by 8d minus 12, it will be 8d minus 12 by 64d square minus 144 sine 2x. Now here we can put minus 4 in place of d square, that is e to the power 3x into 8d plus 12, 8d minus 12 by minus 4 multiplied by 64. So this will be minus 256 minus 144 operating on sine 2x. So this will be e to the power 3x by minus 5 plus 5 10 and 3 plus 1 400. Okay, and 8d minus 12 will operate on sine 2x, so it will be 8 into differentiation of sine 2x, that is 2 sine 2x, so it will be 16 sine 2x cos 2x minus 12 sine 2x. So this is our required particular integral. Now if in place of sine 2x it would be a polynomial, then we should apply the rule for polynomial, which I have discussed in previous video. Okay, the next case is if the function, right hand side function, is the product of a polynomial and sine or cos function. Okay, so what method we will use? I am giving an example. This method is quite lengthy. Suppose there is 1 by d square plus 1 sine x sine x. Okay, x sine 2x. Suppose this is a product of polynomial, x is a polynomial, and sine function. Now to solve this, we are assuming that y equal to this and z equal to 1 by d square plus 1 x cos 2x. If this would be cos, then we assume z as x sine 2x. Okay, now we will find out what will be z plus iy. Always we will take I with the sine function. The reason you will understand now. What will be the result? 1 by d square plus 1 is a common operator. It will operate on x. X is also common. Cos 2x plus I sine 2x. So this will be 1 by d square plus 1 x into, this is equal to e to the power I 2x. You know that the formula of e to the power ix is cos x plus I sin x. So e to the power I 2x will be cos 2x plus I sin 2x. So this is the reason I put I in with y. That is in y or z, in whichever the sine function will be there, I will be multiplied with that function. Okay, so that we can get exponential function. Now this is a product of exponential function and a polynomial, which to solve this function, the method I have discussed just before this method. So it will be e to the power 2ix 1 by, we have to put in place of d plus a. Here a is 2i, so it will be d plus 2i whole square plus 1 operating on x. Okay, this method I have discussed just before starting this method. If the function is a product of an exponential function and polynomial or sine or cos, here this is the product of exponential and polynomial, so I put d equal to d plus a and operating on the remaining function. Okay, so e to the power 2ix, this will be d square plus 4id, and this will be 4i square, that is minus 4 plus 1, this will be minus 3 operating on x. Now we have to apply the method of polynomial. This is a polynomial, and in previous video I have discussed about this method. what to do if the right hand side function is a polynomial. So if the function is a polynomial, I told you that the denominator has to be transformed into the form either of 1 plus x or 1 minus x. Since there is no 1, we have to bring 1 taking common 3. Okay. So we are taking common 3 to the power 2ix by 3. It will be minus 1 plus d square plus 4id by 3 to the power minus 1 operating on x. Okay. Now I am writing here e to the power 2ix by 3. This is the form of minus 1 plus x, and we know that the formula of 1 minus x to the power minus 1 is 1 plus x square plus x cube plus dot dot dot. So here it will be minus 1 minus x, that is t square plus 4id by 3 minus dot dot dot. I didn't write more terms because the function is x and maximum times can be differentiate this function is once. After that the result will be 0. So this will be e to the power 2ix by 3. Minus 1 into x is minus x. Double differentiation of x will be 0, and this will be 4I by 3 into 1 because d of x is 1. Okay. Now again I am applying the formula of e to the power 2ix, that will be cos 2x plus I sin 2x by 3 into minus x minus 4I by 3. Now I will multiply this and I will separate the real part and the imaginary part. Now first I am writing the real terms. Cos 2x by 3 into minus x, that is minus x by 3 cos 2x, this into this, I will get a real term. Now if we multiply this term into this term, this will give us a real part, and that will be minus plus 4 by 9 sin 2x. So this was the real part, plus I into, here I will write the imaginary terms. This term into this term will give us a imaginary term, that will be 4 by 9 cos 2x, and the last term is minus x by 3 into sin 2x. So here we have separated the real part and imaginary part, and we are doing this for z plus iy, which we have assumed. So if we equate both sides, compare both sides, the value of z will be the real part and the value of y will be this imaginary part. Our sum was this, we have to find the value of y. Then comparing both sides, we get that y equal to minus 4 by 9 cos 2x minus x by 3 sin 2x. Hence our solution is complete. So if there is the product of a polynomial and sine function or a cos function, we have to assume if there is sine, we have to assume the other function cos, or if there is cos, we have to assume here sine function. Then we will combine this as this, and we have to write I with the sine function, so that we get e to the power ix function. Then we will apply our previous rules we have learned to solve, and in the last we will compare the real part and imaginary part, and we will get our required result. It may be either y or z, that is either with sine function or cos function. So here this chapter is ended over. All the types variation of functions has been discussed. For which type of function, which method have to be applied. I have discussed 5 types of function and there are 5 methods to solve. Now I will show you some more examples of finding particular integrals. Let us take this example: d plus 1 whole square y equal to e to the power minus x plus x square. I have discussed all the methods of finding particular integrals. This is another examples. So I am not finding complementary function, you know the method. So for finding particular integral, pi equal to this operator will be operated on the right hand side. So 1 by d plus 1 whole square operating on e to the power minus x plus x square. So this operator is operating on both the functions e to the power minus x and x square. So we are splitting for the functions individually. So 1 by d plus 1 whole square operating on x square and e to the power minus x. Now we know if the function is an exponential function, then we have to put the coefficient of x, which is minus 1 here, in place of d. Now if we put minus 1 in place of d, we see that the denominator becomes 0. Then we have to write x and we have to differentiate this function once. So it will be 2d plus 2 e to the power minus x plus, I am splitting this, it will be d square plus 2d plus 1 operating on x square. Now again, since e to the power, this is exponential function, we have to put minus 1 in place of d. And see that if we put minus 1 here in place of d, again it is 0. So we have to bring another x, that will be x square, and again we have to differentiate it. So it will be 2 e to the power minus x plus. And since this is a polynomial, we have to follow the rule for polynomial for finding the particular integral. So we have to bring this function in the form of 1 plus x or 1 minus x to the power minus 1. So this is, there is already a 1. So it will be 1 plus 2d plus d square. I am writing this in this form, to the power minus 1 operating on x square. Now since there is no d, the particular integral for e to the power minus x is this, plus this is 1 plus x. Suppose this is x to the power minus 1. So the formula of 1 plus a to the power minus 1 is 1 minus this, that is 2d, it will be minus, plus x square, that is 2d plus d square whole square minus dot 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 operating on x square. I have not written more terms because you know that if we write more terms, then it will be 0 after operating on x square, because this function can be differentiated maximum 2 times. After first order differentiation it will be 2x, after second order differentiation it will be 2, and after that this will be 0. So more you write, more the terms, the power of d will increase, and that will bring us a result as 0. So it will be x square by 2 e to the power minus x plus, now it will operate on x square. So 1 is operating on x square means it is multiplied. So x square minus 2 into d of x square, that is 2x, first order differentiation of x square, that is 2x. So it will be 4x minus d square of x square, that is second order differentiation of x square, it will be 2 now, plus after splitting this in formula of a plus b whole square, this will be 4d square. So d square of x square will be 2 and there is a constant 4. So 4 into 2, it will be 8. Next, the term will be 2ab, that is 4d cube, and d cube of x square will be 0 because d cube means third order differentiation of x square. And the last term is d to the power 4 and it is also 0. And if you write more terms, the power of d will increase and the result will be 0. So this is our particular integral. We can simplify it: x square by 2 e to the power minus x plus x square minus 4x plus 6. So this is the particular integral for this function. Okay, and you can find the complementary function. So the general solution will be y equal to cf plus pi, where pi is this. Okay. Now we will take another example. Let us take d square minus 4d minus 5y equal to e to the power 2x plus 3 cos 4x plus 3. So pi equal to 1 by d square minus 4d minus 5 operating on e to the power 2x plus 3 cos 4x plus 3. Okay, so now we see that this operator is operating on these two functions. So we are splitting this operator. D square minus 4d minus 5 operating on e to the power 2x. Similarly, minus 4d minus 5 operating on 3 cos 4x plus 3. Okay. Now, since this is an exponential function, we have to put 2 in place of d. Now, if you put here 2 in place of d, the result will be 2 into 2, 4, minus 8 minus 5, and the result is non-zero, so we can put here, so 4 minus 8 minus 5 e to the power 2x plus, since there is cos function, and the rule for sine or cos function I have told you that we have to put d square equal to minus a square, where a is the coefficient of x and here a is 4. That is, we have to put d square equal to minus 16. So 1 by minus 16 minus 4d. Don't put anything in place of d when there will be sine or cos function. Minus 5. So 3 cos 4x plus 3. Okay. Now this will be minus 9, 4 minus 13, 9 e to the power 2x. This is complete. Now we will do for this part. So this is minus 4d minus 21 operating on 3 cos 4x plus 3. Now for sine and cos function, we can put the values of d square only, that is minus a square. D square equal to minus a square, but here is d, so we have to reduce it in some form of d square. So we multiply by 4d minus 21 in the numerator as well as in the denominator, and we are taking common minus from the denominator, so it will be 4d minus 21. We are multiplying by 4d minus 21 in the numerator and denominator, and after taking common minus, it will be 4d plus 21. 4d plus 21 operating on 3 cos 4x plus 3. So it is minus 1 by 9 e to the power 3x minus 4d minus 21 by and this will be a minus b into a plus b, that is a square minus b square. So this will be 16d square minus 21 square, that will be 2142. So this is 441 3 cos 4x plus 3. So this is minus 1 by 9 e to the power 3x minus. Now here we can put minus 16 in place of d square, because for sine function or cos function we have to put minus a square in place of d square. So 4d minus 21, and if we put minus 16 in place of d square, it will be minus 256 minus 441 3 cos 4x plus 3. Now I am removing this, writing here. So minus 1 by 9 e to the power 3x minus, okay, after adding 256 and 441, it will be 7, 4 plus 5, 9, and 4 plus 2, 6, and it will be plus 697, and in the numerator it will be 4d minus 21 operating on 3 cos 4x plus 3. Okay, so minus 1 by 9 e to the power 3x plus 1 by 697. Now the operator is in the numerator, so it is 4d minus 21 operating on 3. 3 is constant, I am taking out this 3, so operating on cos 4x plus 3. Now 1 minus 1 by 9 e to the power 3x plus 3 by 697. Now 4d of this function, that is 4 into differentiation of cos 4x plus 3. So differentiation of cos 4x plus 3 will be minus 4 sin 4x plus 3. So this will be minus 4 sin, so 4 and 4 has been multiplied, it will be 16 sin 4x plus 3. Okay, and minus 21 operating on cos 4x plus 3 means 21 is multiplied by this function, so this will be 21 cos 4x plus 3. Okay, so now we can see that there is no d here, so all the d's are eliminated from the numerator and denominator. And to find particular integral, our main target is to eliminate all the d's, capital D's from the numerator and denominator, then we will get the particular integral. So this is our required particular integral for the given ordinary differential equation. So these were some examples. I am giving you some assignments. You can solve these problems in home, and if you face any problem when you will solve these sums, you can contact me. My contact details is given in the first slide of the video. So write these sums. We'll have to practice this. Number 1, d square plus d plus 1 y x e to the power x cos x. Number 2, d square minus 4d plus 3 operating on y 3 to the power x cos 2x. Number 3, d square plus 4 operating on y equal to x sin x. Number 4, d square minus 3d plus 2 y equal to e to the power x given y 0 equal to 0 and y log 2 equal to 0. I have not solved this type of sums where initial and boundary conditions are given. This is not different from any examples I have shown you. Same procedure, just these conditions are used to find the arbitrary value of the arbitrary constants which comes in the complementary function. We know that in complementary function always two arbitrary constant comes, that are C1 and C2. So after finding the general solution, if you apply these conditions on the general solution, you will get the values of C1 and C2. Okay, so do these sums. If you face any problem, I am there, you can contact me. Okay, so the last assignment is d square plus 4d plus 4 operating on y equal to x square plus 2x. So y 0 equal to 0 and y dashed 0 equal to 0. So these are your assignments. So please do these sums. Okay, so thank you.